So in section 5, we're going to start working with triangles that are not right triangles and work into some new skills on how do we solve triangles that are not right triangles. So remember, the SOHCAHTOA sine is opposite over hypotenuse only works for a right triangle. Now we're going to work with triangles that aren't right triangles. And your vocabulary in this section is you need to know about the law of sines, which I'll go into in just a moment. So what might we use this for? Here's a problem related to biology and breeding regions of a bird. If we wanted to figure out how much area they had, we might work with some of the information from this section. You see, this is not a right triangle. This is the area in which the birds are breeding. How much square footage they have, or square miles, how many square miles they have, might be a determining factor in the success of a breeding program with these birds. So we'll work on this problem later in the lecture, but for now let's take a look at the law of sines. And what the law of sines says essentially is that if you make a ratio between the sine of an angle and the length of the side opposite it, they will always be equal. So if I'm working in a given triangle, the sine of an angle divided by the length of the side opposite it, or I can flip these ratios over, the length of the side divided by sine of the angle. I should use whichever one is going to be the easiest for me in terms of solving my problem. But they'll all be equal. So what that means is that if I have two sides and an angle, or two angles and a side, I can go out ahead and solve out the rest of the triangle. So if you take a look at this particular problem, I have two angles and I have a side. Now, this is angle C, 26 is side C. So I know that angle A is 33 degrees. I know that angle C is 81 degrees. And I also can find angle B because I know that the sum of the angles adds up to 180 degrees. So if I take 81 plus 33, that's 114, and I subtract that from 180, I'll get 66 degrees for angle B. So I know that this is 66 degrees. Okay, so that's a good start. Now, if I want to start finding the sides, I know that if I want to find a side, I'm only going to use this version with the sides in the numerator. So I know that the length of side C is 26, and the sine of 81 degrees, which is the measurement of angle C, will be equal to the length of side A divided by the sine of 33 degrees. And if I want to solve this for side A, I multiply both sides by the sine of 33 degrees. And I have 26 divided by the sine of 81 degrees. Now if I want to go ahead and finish this out and find the length of A, I can go ahead and take 26 divided by the sine of 81 degrees. That equals 26.32 times the sine of 33 degrees, and that's going to be 14.34. Okay, so let me go ahead and write that down. That would make this 14.34. So I know that side A is 14.34. I know that side C is equal to 26, and now I just need to find side B. And I can do this whole process again. I can take 26 divided by the sine of 81 would be equal to side B divided by the sine of 66 degrees. And again, when I go ahead and do this, I'll have sine of 66 degrees times 26 divided by the sine of 81 degrees, will be equal to B. If I go ahead, go back to my calculator, 26 divided by the sine of 81 degrees is 26.32 times the sine of 66. I get 24.08. Okay, now I want to check my answers for validity. Okay, I have solved my triangle, but I want to make sure that it makes sense. Okay, so the longest side would be opposite the longest angle, that's 26. Okay, and you see the other two sides are shorter. And then the next largest side is opposite the next largest angle. They're not that different in size, but the angles aren't that different in size. And when we look at this situation, the smallest angle is opposite the smallest angle, it all makes a lot of sense. Okay, so I'm comfortable with my answer. I'm going to go ahead and move forward. So this works for the case of being supplied two angles and a side, like I was here, and a side adjacent, or two angles and a side between the two, right? Either of these will work. Now, when we look at being provided two sides and an angle, this is called the ambiguous case because you're not sure necessarily what you have. If angle A is an obtuse angle, I might have no triangle and I might have one triangle, and it depends on the relationship of side A to side B. If side A is shorter than B or the same length as B, it won't make a triangle. It'll be too short to make a triangle with this obtuse angle. If A is greater than B, then it will be a triangle. Okay, so this is one check, and it's based on I do one thing if A is obtuse, I do something different if A is acute. Okay, if it's acute, it could have a number of different situations. Now I'm comparing A to the height. And how do I find the height? Height is equal to B times the length of the side B times the sine of angle A. Okay, so I'm going to compare to the height. If the height is greater than A, it won't make a triangle. It won't be long enough to actually hit the base of the triangle. If they're equal, it makes one triangle, and it's a right triangle. If A is greater than B, greater than or equal to B, it will create one triangle. But if A is between H and B, it's smaller than B, but it's greater than H, it can make two different triangles, and therefore I would have to solve for each different angle of this particular triangle, and consequently the length of the base will change dramatically depending. Okay, so when A is acute, I've got a lot of extra work to do to try to figure out what kind of a triangle is this. So let's take a look at what that looks like. Okay, also, this is important. You'll notice that here, in each case, they're talking about a specific angle. They're calling it angle A. That doesn't mean it's going to be angle A in your problem. It might be angle B, it might be angle C. It's whichever one you've been supplied. We're being supplied two sides and an angle that is not between them. Okay, so that's what's important here. The relative lengths of what we're talking about, B is going to be the side adjacent. Okay, so I have an angle and a side adjacent, and that's what we're going to be working with. All right, so let's just go ahead and really quickly sketch our triangle. So I have angle C. Let's say this is side B. B is 20. And let's say this is angle C. And C is 48 degrees. And I know that the side opposite is 28. Okay, so the first thing I'd want to take a look at is I'd want to take a look at the height. What's the height? Okay, so we want, in this case, if you want to think about it the way they wrote it out, C is their angle A. So I want to find that the height is equal to, let's go back and look at the formula. B times the sine of angle A. So in this case, side B is the same, 20, times the sine of the angle supplied, which is 48 degrees. And we want to see what that value is so we can compare it to this other side, side C. So in relation to the way they presented it here in this diagram, you just want to think of side C, angle C as angle A, and side C as side A. Right, so we're going to go ahead and come through here and find out what's the sine of 48 degrees times 20. So my height is equal to 14.86. So you can see that my side opposite is longer than the height, and that means it's going to go, and it's also longer than B. That's going to create a single triangle. So the case that we're in is this one. A is greater than B. Okay, great. So I'm going to go ahead and solve my triangle. And I know that I'm looking now for the angle B is what I want to find. If I find angle B, remember I want to find A, B, and C, and A, B, and C. And some of these are supplied. So they gave me C, it's 48 degrees. They gave me side B, it's 20, and they gave me side C, it's 28. This is what was supplied. Now, the next thing I can really find is I can find angle B. So I know that the sine of B divided by the length of side B is equal to the sine of C, which is 48 degrees, divided by the length of side C, which is 28. Okay, so you'll notice in the previous example, I used a ratio that put the side on top because I was looking for a missing side. Now that I'm looking for a missing angle, I put the angle on top. So I know that the sine of angle B will be equal to 20 times the sine of 48 divided by 28. Okay, but remember, when I find the sine of B, I want to find angle B, so I'll use the inverse sine to find that. So let's go ahead and do that. So I want the sine of 48 divided by the length of side C times the length of side B, and this is the sine of my angle. But if I want to find the angle, so I do inverse sine, 32.06 is the angle. So angle B is 32.06. Now I can find angle A because it's going to be 180 minus 32.06 minus 48. It's 99.94. Okay, so 99.94. And the last thing I want to do is find the length of side A. This is going to be my longest side because A was my longest angle. And now I'm going to put the sides in the numerator, right? So I know that A divided by the sine of 99.94 will be equal to any of the other ratios I already have. I'm going to stick with the original, 28 divided by the sine of 48. Okay, if I go ahead and solve for this, I'll have the sine of 99.94 times 28 divided by the sine of 48. And I'll go back to my calculator. I have 28 divided by the sine of 48 equals some number times the sine of 99.94 equals. So my side would be 37.11. Okay, 37.11. Again, I want to check for validity. Longest side is opposite longest angle. right? The next longest side is opposite the next longest angle. The smallest side is opposite the smallest angle. This all makes sense. And I've solved my triangle. Okay, so sometimes we have no solution. You notice here that, right, A and A, I see that side A is shorter than B, so now I have to check it versus the height. So I know that my height will be equal to the side B times the sine of 52. So let's go ahead and figure that out. So I'm going to find 52 sine times 42 equals, so my height is 33, and you'll see that my side is shorter than that. Okay, and because it's shorter, right, 33.09, actually 33.1 is essentially what I have. So if h is equal to 33.1, 33.1 is greater than 32, that puts us back in this case. The height is greater than the side opposite. My leg is not long enough to get down to the base, so it's no triangle. That's what that looks like. Okay, so that's quick. It's something we just want to be aware of. No solution. Okay, and it's possible also I'll get two solutions. So let's take a look what that looks like. So in this case, I see that my side opposite is shorter than the other side supplied. So again, I want to compare it to the height. The height is equal to 88 times the sine of 70 degrees. And I pull out my trusty calculator, so I find the sine of 70 degrees times 88. It's 82.69. So height is equal to 82.69. So in this case, 82.69 is less than my side opposite, which is 85. So that means this will make a triangle in two different ways. All right? So if this is my height, this can make a triangle going in this direction and also going in that direction. Okay, so that's what happens when the legs of the triangle look like this. Okay, so I need to solve for this a couple of different ways, right? And what's going to happen is I'm going to find a reference angle, right? I've got two different sine values that are going to work out of the law of sines. So let's again start looking at what we know. I know that A is equal to an unknown. I know that B is equal to 70 degrees. And I know that angle C is equal to an unknown. I know that side A is unknown. I know that side B is 85. And I know that side C is 88. And what that's going to let me do is find angle C. So let's think about what we've got here. So now this is angle B. Okay, and this is side B over here, one of these two legs, and this is side C. So we're going to try to find angle C, and I might find a couple of different angles. When I find a couple of different angles, that's going to change angle A as well. So in this case, I'm going to have separate values for A and C. That'll make different lengths of angle C, but it won't change the length of side C. Okay, so I have these extra items to find. Two different lengths for A, two different measures for angle C, and two different measures for angle A. If I'm going to start working here, what I find is that the angle that I can find first right now is angle C. Okay, because I have angle B, side B, and I have side C. That will let me find angle C. So I know that the sine of 70 degrees divided by 85 will be equal to the sine of angle C divided by 88. And then we'll go ahead and solve this through. It's going to be 88 times the sine of 70 divided by 85 will be equal to the sine of C. So let's get out the calculator and figure this out. So I have 70 sine divided by 85 equals times 88 equals, and I get 0.97285. So let's say that's 0.973. And we actually probably want to hang on to this number. If we go ahead and do the inverse sine of this, we'll get an angle, 76.62. Okay, so I know that C is 76.62 degrees. Now, when we think about that, remembering that sine is equal to y, okay? So over here, I have 76.62. Now, what other item is going to have that same sign? Well, it's going to be this angle over here, right, where I have 76.62 as the reference angle. Okay, so if I take 180 minus 76.62, let's go ahead and do minus 180, and then we'll change the sign. So 103.38. Okay, let me write that down really quick. 103.38. And you'll see if we go back and we take the sine of this, we get the same sign that we had before when we solved. So this is what happens is I use the inverse sine function to find an angle, but the reality is there are two angles that have that sine value, and that's what creates this situation. Okay, so now I can go through and I can figure out what's going on. I have 140, right? Let's go ahead and figure out our angles, because that will then allow us to find our sides. So I have 180 minus 76.62 minus 70 equals, So I have 180 minus 76.62 minus 70 equals 33.8. Okay, so in this case, it's 33.8. Now, in this other case, it's going to be very different. So in that case, we're going to have 180 minus 103.38 minus 70, and now it's only 6.62. Okay, so this is going to seriously change the length of side A. Okay, and then what I'll do is I'll go through and I'll do law of sines twice for side A, and I'll be able to figure that out. Okay, so in the first case, where A is 33.8 degrees, I know that A divided by the sine of 33.8 will be equal to, and I like again to work with the original supplied values, because if I've rounded things, it makes things a little complicated. 85 divided by the sine of 70 degrees. So I'm going to multiply both sides by the sine of 33.8. And when we work through and we solve for that, we're going to have 85 divided by the sine of 70 times the sine of 33.8 equals, and I have a length of 50.32. So in this case, A was 50.32. Okay, that makes sense. Smallest angle, smallest side. The ratios look pretty reasonable. But now I want to do the same thing with the sine of 6.62. So let's go back and do that again. So I'm going to have 85 divided by the sine of 70 times the sine of 6.62, and I get 10.43 for the length of my side, 10.43. So again, you see when the angle got much smaller, so did the side get much smaller. Okay, and that's how you solve through it. Remember, why do we do this? We did this because the length of the side opposite was between the length of the side adjacent and the height, okay, which allows it to make contact with the base in two different locations. All right, so go ahead and practice this yourself. We've got a number of practice problems so you can sort of see each eventuality and what those sort of feel like. When you're done with these practice problems, come on back, and we're going to work with area. So we have some very simple formulas for area, right? It basically is 1/2 times 2 sides times the sine of the angle that is not related to the 2 sides. So you'll notice that when you think of the triangle as being composed of pairs of sides, angles on opposite sides, I'm using one of each piece. So I get a side and an angle, and in this case a side and an angle, but I never am using a pair that are matching opposites. Okay, so it's a very easy formula to use. I'm going to have Okay, so it's a very easy formula to use. This one is all set up for me. It's going to be 1/2 times b, which is 13, times c, which is 7, times the sine of 68 degrees, which is angle A. And if I pull out my calculator and I do that, I'm going to have 13 times 7 times the sine of 68, and then I'm going to multiply it by 1/2, which is the same as dividing it by 2, and I get basically 42.19 square units. 42.19 square units. Okay, this one's a little more complicated because you notice they didn't give me 2 sides. So what would I do? Well, I can use the law of sines to find a side. I know that side C divided by the sine of 43 degrees will be equal to side B divided by the sine of 102 degrees. So if I pull out my calculator again, I have 21 divided by the sine of 102 equals some number, and I'm going to multiply that times the sine of 43, and that gives me 14.64 as side C. So side C is 14.64, and now I can go ahead and I can do my problem, which is going to be 1/2 times 14.64 times 21 times, again, I have C, B, I need angle A now, right? Oh, boy, that's so tricky. So I have 102 plus 43, so this is 145, which I take out of 180, and I get 35 degrees, so sine of 35 degrees. Complicated. So they supplied me with enough information to figure it out, but they didn't supply me the information I wanted, did they? Okay, so either way, we can still do it. I've still got my value of C here, times 21, times the sine of 35 degrees, and then times 1/2. 88.18 is my area. So I put a square here. This would be square feet. We could say units squared, whatever we wanted to do. So that's finding the area of a triangle. Give that some practice. Do problems 32, 35, and 38. Come on back and we'll finish out this lecture. Okay, so in this particular case, what they've given me is they've given me information about this area where our black-necked stilts live. So they live all over the place, but they only breed in this little triangular section, and we want to know if there's enough room for the breeding patterns for the population that we have. So what I want to look at is what they've given me is they've given me these different items. So I know that side C is equal to 223 miles. I know that side B is equal to 125 miles. and I know that angle A is equal to 54.2. So this is great. They give me side C, side B, and angle A. That's going to allow me to just pop right into my formula. So I know that it's going to be 1/2 times 223 times 125 times the sine of 54.2 degrees. Okay, my answer, my measurements are in miles. My answer will be in miles squared. Let's go back to our calculator. So I have 223 times 125 times the sine of 54.2 equals, and then if I divide it by 2, which is the same as multiplying by half, it's 11,304.2 square miles. And there's my answer. So this was using the information here from law of sines and the area using sines to find the area of a triangle. In our next section, we'll work with the law of cosines and a formula for finding area based on cosines.